logs, new exercise. Right. So, because of exponential growth, and we found most recently that drawing graphs of exponential functions is difficult. Look at this, for example. See the point 110? Like, no bother, 110. No bother, 2 100s. Will I have any chance of fitting in 3 1000s, 4 10,000, 5 100,000? Am I able to do that? No. Look what happens when I try and draw it on my graph on GeoGebra. It just goes straight up. You have no chance. You can drag it all the way down if you want. Well, look, I'm getting nowhere. Look, I can drag this down, and it's still going straight up. So the lads decided that the scientists at the time said, we need. They were inspired over a few cans, and what they said was, we need a new way of graphing this type of data. So you could imagine something like bacteria that increases our rate of tenfold every week. After 1 week you have 10 bacteria, week 2 you have 100, week 3 you have 1,000. Exponential growth is really, really hard to draw on a graph. So what they came up with was what called the log scale. And I'll explain what the log scale does now. So instead of using regular numbers, what they use is what's called log base 10. So let me explain what log base 10 means. It means how many 10s do I need to make 10? So what do you think the first one will be? It will narrow it down to 1, 1. The next one? What power of 10 is 100? So the answer would be 2, 2. The next one will be, so if you take out your calculator and you press standard log means base 10. And if you put in 1,000, can anybody predict the answer before you even press equals? How many 10s do you need to make 1,000? 3. Oh, sorry. How many times do you have to multiply 10 by itself to make 1,000? 3. Then if you do log a million, how many times do you have to multiply 10 by itself to make 1,000,000? 6. So what they found out is that when you change really big y values to a log scale, you actually change an exponential graph into a what type of graph? Change it into a linear. And linears are easier to draw. And you notice that I don't need to go from 1 to 1,000,000 anymore. I just need to go from 1 to 10, 100. 1 to 10,000 is now done with 1 to 4. Okay. Now, in order to make this system work, they needed to introduce a bunch of rules that work. Okay. So let's start off really, really quickly. So anytime you press log in your calculator, it automatically has a base number of 10. Everybody cool with that? So we've already discussed earlier, what's 1,000? Log 1,000 base 10. What's log 1,000 base 10? Anybody? 3. Sweet. Can anybody tell me what log 8 base 2 is? How many 2's do I need to make 8? 3. Is that okay with you guys? Next thing. What is log 243 base 3? How many 3's do I need to make 243? Now, if you put this into your calculator like this, why will you get the answer wrong? That's not base 3, that's base 10. That's not what I'm looking for. So what button does that instead? This over here, isn't it? And how many 3's does it take to make 243? 5. Everybody cool with that? This button here, buddy. Do you have a different calculator? No, sorry. Well, good. Now, the next thing we're going to do after that, guys, is I'm going to describe something to you, alright? Maths, what I keep telling my TYs is maths is more about space than it is about the numbers, okay? So, for example, is yellow, 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 blue, 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 and then green, green, green. Can anybody tell me, what is the yellow one on its own? What does the yellow one on its own equal? Anybody? It always equals blue to the power of green. Check it out for any of them, and I bet you it works. 1,000 is the same as 10 to the power of 3. What about the last one? 243 is equal to? Anybody? 243 is equal to? So, does everybody know how to remove a log? I've now successfully removed the log, haven't I? So if you want to remove the log function, simply send the blue part up beside the green part, and then the log disappears. Everybody cool with that? Awesome. Now, next thing. We discussed earlier, what's 10 to the power 0? What's 2 to the power 0? What's 3 to the power 0? What's x to the power 0? Therefore, no, it doesn't matter what the base is. Doesn't matter what the base is. Okay? If, I'll just make sure I do this correctly. Log 1, doesn't matter what base it is always 0. Why is log 1 always 0? Because 1 will equal 10 to the power 0, 1 equals 2 to the power 0, and 1 equals 3 to the power 0. Is everybody cool with that rule there then? All good? Okay. Now, let's move on. Alright, I've explained the first rule pretty good, alright? Now time to move on. Now, in law 1, they have to be the same base. So, here's what you can do. I could say log, for argument's sake, log 4 base 2 plus log 8 base 2. What's log 4 base 2, anybody? How many 2's do we need to make 4? 2. How many times do we need to multiply 2 by itself to make 8? So the answer would be 5. Alright? This is called the multiply rule. Multiply 8 by 4 and what do you get? Log what? 32. How many 2's do you need to multiply by themselves to make 32? 5. So do you see the way that works? When you're adding logs of the same base, just multiply the numbers together and you get 32. I'll give you another one. Log 3 base 9 plus log 3 base 243. Can anybody tell me what the answer be over this side? What would you do? 9 multiplied by 243. And what's 9 times 243? 2,187. If you aren't sure about it, check it out. That's 2. That one is 5. And this one will be 7. It'll work. Right. Is everybody happy with law 1? The adding logs together. Yeah? Now, next thing. What happens when you take logs away? I'll go back to my initial one. Everybody cool with this? Oh, yeah, I gotta do that as well. Alright, give me a second. Alright, guys. We're gonna work backwards now, right? Ready for this? 3 squared equals 9. Everybody cool with that? What does that mean? Log 9 base 3 is what? You all cool with that? Let's try another one. 3 to the power of minus 2 is what? 3 to the power of minus 2 is 1/9. What's log 1/9 to the power base 3? Minus 2. How many 3's do you need to make a 9th? Well, it's actually 3 to the power of minus 2. That would be a 9th. Is that okay? So, if I gave you a question like this, I'll give you 2 of them. Here's the first one. If I gave you log, this is all off the top of my head. 16 base 2. Take away log 64 base 2. What's the answer? Just normally, if you were to do it in the calculator. What's the answer for the first one? 4. Second one? 4 take away 6? Minus 2 is the answer, isn't it? Now, if we're to use the take away rule, what does it say about the take away rule? If this is the green one, that's the yellow one, then the answer is the green one divided by the yellow one. So what's the answer for this then? Log 16 over, and log 2. What's 16 over 64? A quarter. And does everybody remember this? 2 to the power 0 is 1. 2 to the power minus 1 is a half. 2 to the power minus 2. What's the answer? Minus 2 as well. That's the adding effect of logs. Everybody cool with that? Now, next thing. So we've done this one. We've done this one. We've done this one. Now we got to move on to log number 3. Alright. Oh dear. Hold it. Now. Alright, get this. Log 10 base 10 and log 10,000 base 10. Okay, what's the first answer? 1. What's the second answer? 3. Go with that? I'm going to change this. What can I change that into? 10 to the power of 3. You go with that? There's a rule. If you have a power that I'll highlight in blue, see the power? You can bring that power to the front. So can everybody guess my next step? What happens to that 3? 3 log. And what is 3 log 10 base 10? Log 10 base 10 is 1. What's 3 times 1? Still the same answer, isn't it? Didn't matter what way I did it, it was still the same answer. So one more time. If I have something like this, if I have log 16 base 2, what can I change 16 into? To the power of 4. What can I do to 4? Bring it to the front. And what is log 2 base 2? 1. And the answer will be 4. If you threw that into the calculator at the beginning, it would also be 4. There's a reason I'm doing this. Put it that way. Otherwise, they're just like, use your calculator, everything's cool. It's not cool, it's going to get tough. Alright? Now, nextly, any number to the same base. Log 10 base 10, anybody? Log x base x? Log Kenny base Kenny? Anything to the same base is always 1. Finally, the most difficult one. The good one. I like this one. Of course I like this one. Alright. I'm going to give you an awkward one here. A and... Maybe A and... not A. Log 4, 16, 4, 32 base 4. Alright. Log 32 base 4. You can choose an in-between base if you want. So I'll give you an example. Log 32 base 4, you can throw it into the calculator to get the answer, no bother, right? So log 4 on the bottom, 32 on top, what's the answer? 5 over 2, which is 2.5. Everybody cool with that? Now, anybody, what's log 32 over log 4? Check it out. Log 32 divided by log 4. What is it? Same answer. Everybody see that? What base did I give them here? I gave them a new base. I gave them base 10, didn't I? I can choose any base I want, and that will still work. What happens if I choose 2 instead? Log 32 base 2 and log 4 base 2. What would the top one be? Top one's going to be 5 and the bottom one's going to be 2. Doesn't matter. Okay? If I said this is log x base 5, what can I do there? What can I say that's the same as? Anybody? Give me something that's the same as. Log x, any base you want, divided by log 5, same base. You got it? And that's your last rule done. Now, how did these rules actually work in actual questions? You guys are probably only going to do the first 4 questions tonight anyway, so let's have a look at these ones here. Right. Alright, anybody know how to do this one? Log base a third 27 equals x. What did we say earlier? What did we say earlier? Different colours this time. Blue 1 equals yellow 1 to the power of green. Really? That's going to be interesting. Why do I have to change it to index form? I actually don't. Could I not just put that in my calculator? Why do I not just put that into my calculator? Yeah, but look, if I was to do this, I know I'll do that in a second, but look at this. The answer is -3. Fair enough. Let's figure that out. Right. 27 equals a third to the power of x. You okay with that? Now, what can I do with the power? I can say 27 equals 1 to the power of x divided by 3 to the power of x. What is 1 to the power of anything? 1. Awesome. Bring the 3 to the power of x from bottom right to top left. Bring the 27 from top left to bottom right. Then what do I do? Change 27 into 3 to the power of 3. And 3 to the power of x equals 3 to the power minus 3. X equals 3. Alright? Now, finally, this one here. I don't understand why you just wouldn't throw it into the calculator. This one's root 27. Just stick with me a sec, lads. I'll be done now in a second. This is root 27. What's down here? 3. The answer is 3 over 2. X equals 3 over 2. Now, there's no reason why you just wouldn't put that into the calculator. Right? So, for the weekend, try questions 1 to 4. You're done.